We're going to do problem 85 from the Calculus AB BC Summer Review Packet. Okay, so anyway, we're going to use our trig IDs and our unit circle to solve this problem. So let's get started right here with some trigonometric identities. We have a mix of cosine and sine. That's a key to us that we want to convert them both into either both being cosine or both being sine. It's going to be easier to convert the cosine because of our Pythagorean identities and our magic hexagon. Cosine squared plus sine squared equals 1. So we're going to change our cosine square into something else with one of our identities. So like I just said, cosine squared plus sine squared equals 1. We can get the cosine square by itself if we move our sine square over. So we get cosine squared equals 1, and then we've moved this so it's minus sine squared. So we are going to change this to be 1 minus sine squared. Okay, then copy down the rest of the problem. All right, and we will combine our ones together. The 1 plus the 1 over here makes 2, so we've got the negative sine squared and the positive sign, and the plus 2 equals 0. Now we're going to have to factor. This is a trinomial. We've got the square, regular term, a constant number. We're going to need to factor this. I don't want to factor out a negative, so I am just going to pretend that I've moved everybody over to the other side of the equal sign. That's going to change this into a positive sine square. This is going to be a negative sine x, and this is going to be a negative 2. All right, factor a trinomial, and we can do this. It's a little weird with the signs in there, but it's just a trinomial. This is like a 1, this is like a 1, that's obviously a 2. We want to think to ourselves, what adds up to negative 1 and multiplies to negative 2. So I'm thinking it's going to be negative 2 positive 1. Like that. And so this sine squares, you're going to split your sine square off into a sine in the first factor and a sine in the second factor. And then we're going to put in our minus 2 and our plus 1. We're going to need to solve this, so we know that to solve it, we have to set it equal to 0, set each whole factor equal to 0. And then, move those numbers over to solve. So we have sine, oh, you should probably put the x there. Sine equals, move that over, so positive 2, and move this over, sine equals negative 1. And then we want to figure out where on the unit circle are we going to find sine coordinates with either 2 or negative 1. Now, we are never going to find anywhere on the unit circle a sine coordinate of 2, so we're just not going to worry about this. That just isn't going to work out. Where can we find a sine coordinate of negative 1? Think about your unit circle. I'm not going to draw the whole thing, just don't feel like it. But we know that at the bottom of the unit circle, We know that down here the coordinate is 0, -1. We know that the x-coordinate goes with cosine, and the sine coordinate and the y-coordinate, they're the same thing. So it's down here where we have a sine coordinate of -1. And so this angle down here is either 270 degrees or 3 pi over 2. So the answer to the problem, they seem to have theirs in radians. The answer to the problem, where can you find a sine coordinate of -1? The answer is 3 pi over 2. Thanks for watching. If you need tutoring to get you through your review packet, or if you need tutoring during the school year to get through calculus, please contact me. My contact information is in the description and also at the end of the video. Thanks for watching.